elevation of boiling point. Elevation of boiling point. First, what is definition of boiling point? The characteristic temperature at which vapor pressure over the surface of liquid is equal to external pressure or atmospheric pressure. Is called boiling point of liquid. Suppose a sample of water is heated and a thermometer is kept into the water sample. Now, as temperature increases, the temperature in thermometer started rising. At the same time, vapor pressure also increases. Atmospheric pressure that is pressure of air is equal to 1 atm suppose. So as soon as the vapor pressure of liquid during the heating of liquid becomes equal to 1 atmospheric pressure, the rise of temperature stops. Rise of temperature in thermometer stops. Suppose this temperature is 100 degrees Celsius. So now, until all the liquids present in the sample will not be converted into vapor, the temperature will remain 100. That means as soon as the vapor pressure of liquid becomes equal to external pressure or atmospheric pressure, the temperature remains constant, and that temperature is called boiling point. So at 1 atmospheric pressure, boiling point of water is 100 degrees Celsius. This is called boiling point of water. What happens when some solute is added into liquid? Now, by adding, let us discuss elevation of boiling point. Elevation of boiling point. When a non-volatile solute is added into solvent, suppose in water, some space at the surface occupied by solute molecules. This reduces the vapor pressure of solution. In that case, the liquid, therefore, the liquid must be heated more to reach atmospheric pressure. Therefore, or thus, boiling point of solution containing non-volatile solute is elevated or is higher. This phenomenon is called elevation of boiling point. Elevation of boiling point. The elevation of boiling point can better be explained by drawing graph. So let me draw graph between vapor pressure of liquid and its solution with or against temperature. So let it be, this is at 1 atmospheric pressure. This is atmospheric pressure 1 atm. External pressure or it is atmospheric pressure. Y-axis I am going to draw vapor pressure, as we go up vapor pressure increases, and in x-axis temperature. From left to right, temperature increases. So from left to right, temperature increases. From bottom to up side, vapor pressure increases. What happens if pure water is taken? The vapor pressure at lower temperature is low, and as started heating, the vapor pressure started increasing, and at a particular temperature, suppose at 100 degrees Celsius, the solvent or the water, which is in pure state now, boils. At 1 atmospheric pressure, the vapor pressure becomes equal to external pressure, and that temperature is called boiling point of water. It should be taken as TB naught. Now suppose some solute, some non-volatile solute, suppose sugar is added into that water sample. Then what will happen? Vapor pressure lowers, and now by heating again, vapor pressure started increasing. So at higher temperature, more than 100 degrees Celsius, the vapor pressure of solution is equal to vapor atmospheric pressure or external pressure. As soon as the vapor pressure of solution becomes equal to external pressure, that particular temperature is called boiling point of solution. It is TB. The difference between TB naught and TB is called elevation of boiling point. This is called elevation of boiling point. So now you can very well understand that due to decrease in vapor pressure on adding solute, non-volatile solute, the boiling point increased. Once again, as we are adding some solute in solvent, that solute which is non-volatile, when it is added, the vapor pressure of liquid lowers, decreased, and to increase the vapor pressure up to equal to external pressure, more heat is to be supplied, and that's why the boiling point of solution is higher than the boiling point of pure solvent. Now suppose TB naught is boiling point of pure solvent and TB is boiling point of solution, then delta TB minus delta TB naught is equal to TB delta TB, which is equal to elevation in boiling point. Elevation in boiling point. The magnitude of boiling point elevation is directly proportional to molality of solution. Molality of solution. Therefore, delta TB is equal to Kb into molality, where Kb is constant. Where Kb is constant and it is known as ebulioscopic constant. Ebulioscopic constant or molar elevation constant. Kb is defined as the elevation of boiling point for 1 molar solution is called molar elevation constant. Molar elevation constant, that is Kb of water, is equal to 0.512 degrees C per molar. So minus sign should be given here. So we are now knowing the Kb, we are now knowing the delta TB. So to solve some numerical problems, we should also know molality of solution. That means small m is equal to number of moles of solute by mass of solvent in kg, or the formula should also be given as W1 into 1000 W1 into 1000 by M1 into W2. So this formula will be very useful in solving the numericals, where W1 is mass of solute in gram, m1 is molar mass of solute m2 no, w2 is mass of solvent in gram. So by knowing W1, M1 and W2, we can determine the molality of solution. Let us solve some very important numerical problems which either asked in previous examination of JEE or NEET or may be asked in next examination. But before going into that, one more formula should be given, that is Van 't Hoff's factor Van 't Hoff factor, that is I. This is applied in colligative property when a solute associate or dissociate. If given solute dissociates or associates in solution, then the equation for elevation of boiling point should be written as delta TB equal to I into KB into M. Where, take example where I is Van 't Hoff's factor. For example, NaCl is solute. In that case, 1 mole NaCl dissociates into 2 mole ions, and the value of I 2. Similarly, if solute is calcium chloride, it dissociates as 2Cl minus plus Ca2 plus. So here the value of I is 3. Let me write clearly the value of I in all the two cases. Here I, that means Van 't Hoff factor, is 2, and in this case I is equal to 3, so value of I is 3. Now I am writing here some numerical problems which a student will try to solve. It will be very important for competitive examination. Question number 1. 1 gram of a non-volatile solute is dissolved in 100 gram of water. The boiling point point of solution increases by 0.52 K. Given Kb for water is equal to 0.52 K Kelvin kg per mole. Find out molar mass of solute. Molar mass of solute. Here I am writing the answer. A student himself or herself try to solve this question. The molar mass of solute is equal to 10 gram per mole. This is the answer. Now next question. Question number 2. 2 gram of a non-volatile solute is dissolved in 100 gram benzene. The molar mass of molar mass of solute 100 gram per mole given Kb for benzene is 2.53 Kelvin kg per mole. Calculate elevation of boiling point. Answer is point delta TB is equal to 0.506 Kelvin. Molar mass of solute is 100. Okay. Now next question, third. The boiling point of water boiling point of water increases by 0.104 Kelvin when 1 gram of a non-volatile solute is dissolved in 100 gram of water. Kb for water is 0.52 Kelvin kg per mole. Find molar mass of solute. Answer is 50 gram per mole. Let us discuss two very important real life application of elevation of boil point. Real life application of elevation of boiling point. Number 1, cooking with salt or sugar. Cooking with salt or sugar by adding salt, the boiling point of solution is higher than 100 degrees Celsius. Food such as rice, vegetable, pasta, cooked cooks slightly at higher slightly faster than without adding salt or sugar. So these can be cooked fast if in water some salt or sugar is added into water before boiling. Next application is why car radiator do not boil even high engine temperature. This is because of the presence of ethylene glycol. Equivalent the substance like ethylene glycol is mixed with water, the solution water plus glycol, ethylene glycol, known as coolant can absorb more heat without getting boiled. Thus, the engine remains cool and safe from overheating. Now I'm ending this video today, and in the next video I shall discuss depression of freezing point, elevation of boiling point, addition of solute lowers the vapor pressure of solvent. In our next discussion, we will study the depression of freezing point, one of the most powerful colligative properties used in chemistry and in biology, etc. Thank you. See you in the next video. Thanks.